Hello folks, well today we've got a Harvard 420M from an end user. So this, I put it on the duster because it's been recently repainted and the right colour at that, so that's something I don't want to spoil. The customer says something about the meter doesn't move. Now I don't know whether that means the meter doesn't move as in the meter's faulty, or whether the radio is actually faulty and the meter doesn't move. So it's come with the factory original mic. Although we'll test that, we will do all our servicing work using our standard replacement mic, and you will see they are both coffin mics, but of course they'll have different innards. You know this is real because it says Japan on the bottom. Ours doesn't. So the first thing I want is actually a power lead. Now it's come with a power lead, which I doubt will even take 1 amp, so not quite sure how good that's going to be. Anyway, I'm going to get one of our power leads from stock, which are 3 amp rated. So I'll get that. See how kind we are. We get these new ones from stock and we test them on a repair, and then we put them back in stock so people get them knowing they work. PDI seems to have disappeared, hasn't it, these days? Pre-delivery inspection. When I had the television shop, we used to set up the power supplies in the telly, because it was a bit of a naughty thing, you know. They've got them set high. If it was a sales set, they got them set low. If it was a rental set, the set lasted longer. And so of course we'd set them low. For example, the telly I'm thinking of, the high tension was 200 and I think it was 207 volts. And if you set it to 197 for rental use, the picture didn't quite fill the screen. So we used to set it to something like 201, so it just filled the screen. But if these things were bought, they'd set them at 212, you know, to wear it out quickly. Very, very naughty. So we used to PDI these things, set up the convergence and everything. Because I'm going back to the 80s and even the 70s, and then we'd have them on soak test for 40 hours and then put them back in the box for PDI'd. And this lady came in and she wanted one of these particular tellies. And I said, well, actually, I've just got one which is coming off test any time. Oh, I want a new one. It's like I'm kind of unboxing them, and I don't know what she thought I was doing. But, so I gave her one in a sealed box, you know. But that's not how we worked. If we were selling new CB radios, they'd be unboxed, they'd be serviced, and that fee would be on top, so it'd be full recommended price, probably even plus. But it's the value added service that you're getting. It's all right, people comparing box prices, and then the next thing they've got to pay for service. The weird thing, CB radios, because they never did come out of the box right, and they still don't. That said, of course, we've been testing some of the Thunderpole ones, as you know, and they're more or less how they should be. Right, and it's the only firm I can say that of. And I'm not paid to say that. Right, here we go. Power supply on. Let's connect our short-circuiting crocodile clips to it. I'm going to go straight in at 13.8 volts because he's obviously tried it. It's not like it's been dormant forever. So we're plugged into the test gear, plug in our standard mic. Especially if I can get it to go into the locking ring. So we're in PA, it's how it's come. Testing 1 2, testing 1 2 3 1 2. Okay. What we want is a job sheet. Tomorrow we'll have a Harrier, which is one of our sets. I'm going to show you some new fronts that Andrew at Lake Vintage Electronics made for us. About the 8th. I think it was only today I haven't got a church service, and it's like that in December, and we might be alright tomorrow, but Wednesday I've got a funeral, and you know, it's alright, you think, well, the funeral's only 15 minutes, but you know, I'm there an hour before, I'm there after, so by the time you've actually gone there and done it, you've taken 3 hours out, you know, it's not just the service time. Right, so Harvard, these are my favourite CB radio of all time. It's a really good kind of compromise between being a top performing radio. Tell you what, it's still got the plastic on the back, it doesn't look like it's been fagged on. 20114949. So it's a good compromise between the upper end chassis of the Cybernet 134. You know, they've got them in kind of in 2 tiers. The one with the 3 tiers. There's the base station version as well, which has an extra receive bit. So the radios like the Harvard start again. The radios like the Rotel 220, York 861, Bannertone Speedway. Those lower end Cybernet 134s don't have one of the receiver circuits. Doesn't affect the performance apart from bleed over, and that doesn't matter an iota to me, but it does to some people live in towns. So you've got 3 tiers of the Cybernet 134, and this is the upper tier for a mobile, and yet it doesn't have piles of stupid knobs like the Rotel 240 and the York 863, and some of those others just got too many knobs. I mean, tone's useful, though we tend to leave it in high. RF gain's useful if you're in a convoy, but then if you've got low power, that's fine. You don't need channel 9. I'm not really sure what the excitement over that was. CB mode. So there we go, we'll put it on channel 20. And is the radio doing anything? He says the meter doesn't do anything. Well, in actual fact, the radio doesn't do anything. Okay, so the radio doesn't do anything, and let's put the signal generator on. I don't think the synthesizer's running. I've got 100 microvolts on the signal generator, and there's nothing. Well, we're going to have to take all the lids off, aren't we? So we could well have I just hope it hasn't been messed with, and we've got to start all this demodification of illegal mods. I really, really hope we haven't got that. I'll have to ask him what colour he used to spray this, because it's the right colour. I know Knights used to sell the paint, but we didn't get on with that aerosol. It just seemed not to work for us. It seemed to be all blotchy, and despite how you prepared the surface, I could get my RAL chart out, couldn't I? Because this and the Rotels, well, they came out of the same factory anyway, the same colour. We're taking all the screws out because clearly we're going to have to get underneath. So I'll take the bottom lid off. We can't see anything silly. HV, eh? Has that had holes filled, do you think? Well, good job anyway. Get the bigger speaker. There's your extra receive stage. On the base station is an extra one there. So, what are we going to find here? We could see for a start whether the crystal has corroded its leads through. We could look for stupidly dry joints in the phase lock loop department. So if these get a miscode, theoretically, in other words, if the channel selector switch was snapped off, they should assume emergency and go to channel 9. So a miscode wouldn't give you no results. Now these sets have got a channel 9 switch, so I'm going to switch the set back on channel 9 and see if it goes into transmit. No, because that directly accesses and eliminates all the channel selector, shall we say, mechanism. As I've said before, I've no idea where our usual test meter is. And you know what? I can't find the posher one, but this one's turned up. I think the mice are moving things around. Right, we want a crocodile clip lead to connect our negative to chassis. And I don't mean that chassis, I mean the proper one, because these are floating. Test point is there. 125 millivolts. Transmit, what? 100 and something millivolts. Before we start going into all kinds of clever electronics things, I think I'm going to do the VCO for dry joints. I can tell you why I say that, and they don't suffer really. That is dry joint. It's just started to get that halo round it. One or two of these have just started to get a halo round. I haven't got the right solder here. I'll see if we can use the thicker solder. Otherwise I'll have to go and borrow some from a certain Mr. Chippie's bench. I've now lost where I was. It was there. think that's what I can see immediately. Some of these are just potential dry joints. Somebody soldered around the face like loop chip in a not too distant past. Switch it back on. Oh ho ho! It transmits. Who's a clever boy? Okay. See whether we've got VCO. See, instead of fiddling around adjusting things, try and find why it's gone off, because the VCO core's been moved, but so it should be 4 volts on receive and 4 volts on transmit. Let's put picture in picture on, and we'll select the main meter. We want 4 volts on transmit on channel 40, and we want 4 volts on receive. I'm going to do receive first because transmit might just come right. So we'll call that 4 volts, and that's going back into transmit. 4.4. So I'll need to adjust. I'll use the other tool, the red trimmer for transmit, to 4 volts. That'll do me. Let's go back to receive. 3.98. They are interactive, so you might have to go backwards and forwards. You know, this isn't. I'm being more spot on in this demonstration than reality dictates. So that's receive, that's transmit. There we go. So that's the VCO done. No PLL operation, dry joints in VCO. This was pretty equal, wasn't it? 2.6 plus 2.6, and it's now 4 plus 4 where it should be. Let's look at frequency. I think everything's warmed up enough for this to be now correct. 2799. Oh, we're on channel 40. Let's do channel 20. 2779069. 2779069. So it's now starting to be lower than normal, and people would notice it's not illegally out. So let's do that while we're at it. Sure, I'm showing you that. Wonder when this last worked. Look at that, it's gone, no problem at all. Beautiful. 2779125. Let's have a little look at deviation on this test set for what it's worth. Wallow. We have no transmit audio. Why is that? Have I got the? Do these have mic gain? No. So just listen on our walkie-talkie. Testing 1 2. Testing 1 2. There is no transmitted audio on this radio, but there's public address audio. Let's go back to public address. Testing 1 2. Testing 1 2. Testing 1 2. I'm going to turn the set off, and I'm just going to, just in case, we'll just do the, just in case it's there. I could apply switch cleaner, but I'd rather not unless I have to. So I'll tell you what, we'll start back off in PA. Testing 1 2, testing 1 2. Put that walkie-talkie back on, which I should never have turned off. Go back to CB. Testing 1 2, testing 1 2. No, there's no transmitted audio. Okay, well that's going to be a giggle, isn't it? I'll just take that to there while we're at it. Just see whether we can hear any transmitted audio with me putting my finger as a signal injector onto the deviation control. So I'm going to key up, we'll monitor it on my walkie-talkie at high volume. Nothing there, nothing there. But it's not getting there, is it? No, Mr. Tango. But it's getting there. Let's see whether it's coming out of the speech processor chip. Without looking at what pin does what. Just somewhere between the speech processor chip and capacitor 25, it's going missing. We'll worry about that later. No TX audio. So when we key it up on full power, what's the meter read? Spot on the 4. Meter lamp works, PA works, the sockets all work. Let's look at transmit power then. So we're on the 30 watt scale on this test set, so 4 watts is there. Let's go to the 3 watt scale. It's doing just under 3 watts, but we'll give it 3 watts. It's 3 watts. Channel 1. 3 watts, nicely balanced. Remember, these are supposed, the factory sets them to 3.8, not 4. We set them to 4. Low power should be 400 milliwatts. It is 5675 milliwatts. Back to normal power. And the current consumption is 944 milliamps. We'll just put some switch cleaner on that low power preset. That can be soaking in. That's normally the snag. We'll come back to that later when we do the transmitter. So let's go to receive and we'll plug in our test equipment. We'll want that extra earth. Just like that. That sounds very, very strangled. It's because my earth wasn't on. Let's make sure RF gains to full, tone about 2/3, squelch down, and let's see what the cyanide meter has to say. It sounds very good at S9, and the meter is showing. That's interesting. It's not the meter doesn't work, but the meter's showing 1. For the meter to read S9, it needs to be 100 millivolts for S9, which is as deaf as a post meter. Not 100 microvolts where it's supposed to be. That's definitely finger trouble rather than fault. Let's see where the sensitivity is then. Just making sure we're on frequency 27.79126. We are. Oh, it's pretty deaf. Where's RF gain? RF gain's dirty. So full isn't full. Waggle that about a bit. Let's see where we are now with sensitivity. Very good. So at the moment we have got a very good 0.3 microvolts for 12 dB synad, which is better than what the manufacturer says it will do. And that's before I've even touched it. I'll probably fix it worse. 0.27 and yeah, 0.75. Let's see how squelch is working. Squelch to full. Show you the attenuator. Get rid of that fidelity board. 100 microvolts for opening. It's exactly 100 microvolts. It's where it should be. Minimum. Set threshold on the radio. Signal generator back on. 0.5, which is excellent. So it's strange, some things have been fiddled with and some things are spot on. Right, let's go through the transmitter. And I think that one was done with. So transmit, making sure I'm on the 1.5mm tool and not the 2. Put the transmit test set into transmit and disconnect my earth so I don't get feedback. That can go to 30 watt scale. We're detuning it and retuning it so we've got the peak centered exactly where we want it on channel 20. Detune, find the peak. There we go. So that's those done, and they were basically where they should be. What we'll now do is the other ones. I'll use this tool set, the Velleman VTP1, and Gareth at Leeds has copied these for us, and I think he ought to offer these for sale. This is the blue equivalent one. So we want this to full. This is temporary. Never leave it in full thinking you're going to get miles better range, apart from the legality side, with it being a 4 watt legal limit. It'll just cook this PA. Okay, so what they want you to be able to do is to get 4.4 watts to do this balancing act. This radio is doing 4.6 at full whack. So we need to turn the yellow on right. Remember, this is an on channel 20. Until we get 4.4 watts, which is there. Then we need to turn the green one anti-clockwise left till we get, they say 3.8 watts, but we're of course setting it to 4 because we're entitled to it. They have to get the radio through customs, we don't. So we're now on 4 watts on channel 20. We're on 4 watts on channel 40. And we're on 4 watts on channel 1. So that's balanced out beautifully. Remembers to return the radio to channel 20. When we bought that Midland 76900 bass we use, it was at full whack. Some Wally left it in what we'd call service mode. And then, you know, you start with the melted inductors, and where do we get those from? Well, by smashing up another set. You're not going to buy them, are you? It's just bonkers. This radio frequency choke, there's a plastic covered one down there, and that's the main one that is killed. Then these go tight and you can't move, and it cracks the cores and it goes on. Okay, so we've got 4 watts. Let's now adjust the meter to say it's doing 4 watts, because it now says we're doing 5. And set that to 4. Just like that. We'll do low power. So that wasn't working. We've sprayed it already. So let's give that a waggle. That's now doing 400 milliwatts. Put that back to normal. So we can run down this 4 watts, 4 watts. 4 watts, can make a song about this. 400 milliwatts, which is 10 dB, is what the rule said. And our current consumption is now 1.142 amps. So there we go. I've done the meter and it now reads 4, and that's correct. Let's go to the receiver, because I'm going to worry about the no transmitted audio later. And because we know it works on public address, so we know it's at least half of this chip is operational, otherwise it wouldn't do public address. So the only fault could be the other half of the IC, which I don't think it is, or a dry joint somewhere between here and there, or some capacitor open circuit or something. But I don't think I think it's going to be another dry joint. And I wasn't looking there, of course, when I did dry joints. I was looking in the VCO. So here we go. Receive. Get my earth back on. Not that one. That one. So we'll start with the 100 microvolt signal. We'll look at the oscilloscope and check the detector. I don't think the receiver's been fiddled with on this. That was virtually the right place. We'll now do the IF. That was spot on right. The next one. Spot on right. Spot on right. None of those have been fiddled with. all perfect. Let's go to the front end, go to the cyanide meter for you, and let's go through these. That was out. There we are. Just that one which was out. Little touch up on those two. Let's see what our new readings are. Naught 0.21 microvolts, 0.2 microvolts, 0.35 microvolts. Is squelch still right? Let's find out. I did press the button, nothing happened. There we go. 3, 10, 30, 100. It's still correct. So we don't have to adjust the preset there. And our squelch sensitivity is 0.5. And I think the pen went on the floor. So they remain the same with no adjustment necessary. The meter, let's put 100 microvolts on the signal generator. It still needs to come up. So that's now S9 for 100 microvolts, as it should be for a UK CB radio. I'm not going to sign those off yet. Okay, so let's look underneath again. Am I going around in circles with this? So we know the speech processor's there. We know the varicap diode is there. We know it's coming up to there. So somewhere between there and there, I think there's a dry joint. So we'll have a look at this first, because that would be the easier bit of fault finding. Power back on. Testing 1, 2. Hello, what we're going to do is change the speech processor chip. It's 4558. Especially if I don't drop them on the floor. I've changed the 33 microfarad capacitor on which feeds the varactor diode. Where is it on the circuit? That one, 140. I've changed that. Japan Radio Corporation, Japan Radio Company, and so they are probably higher quality than what were originally installed. I've seen JRC ones, I'm sure I have, in Cybernet radios. This radio certainly isn't fitted with JRC. It is frustrating because if it works on PA, you know half of this is working. It's basically used as 2 preamps. I don't attempt to recover these in one piece. They're not going back in. What I'm just going to do though is check that it goes in from the other side. Of course, new chips pin spacing can be interesting. It's easier to test it on this side than the other. Oh, we're losing some print there. Yeah, that's recovered it. I will go over that later with isopropyl and see whether it works. Okay, so we've got back transmitted audio when we're not touching the power leads. Testing 1 2, testing 1 2. Testing 1 2 3 1 2. Right, so we'll plug into, see what the deviation is on this test set, and then we'll plug into the one behind for accuracy. Wow, it's showing about 1.5 on this one. Just another really cracking receiver. It's actually 1.5, but then I did adjust the AGC. So there we go. That's it. So it spent its life doing 3 watts. So it's not been thrashed, has it? That's great. Someone's going to get a really nice radio. I'm sure he'll tell me where he bought it from. I did have to get the big diagrams out to get to the bottom of that. We're getting quite a spate of sets with no transmitted audio, and usually it's capacitors. So the capacitor I changed, you saw on the underside, the 33 microfarad, it was just part of Diagnostics. I mean, they're only pence. So let's see what it reads on this test set. Well, it reads about 2, so that's lying today. So it's 2.2 to 2.5 kilohertz. Replace 33 microfarads. NJM 455. I think that's everything. So make sure the meter says something sensible in transmit. It does. Make sure the meter reads something sensible in receive. I need to just change my speakers over, don't I? So that's 100 microvolts. And it is 100 microvolts. Just so we can get some more switch cleaner into that, and we're done. I'll get that put back together. I may as well pause the video. Can't get service into the RF gain properly, so we're having to take the potentiometer off. There's an access hole, usually, on this side. Yep, there is. So we can get the switch cleaner in here. And I'll treat the volume control in the same way while we've got the front off. You have to unsolder the earth for the mic socket, so it's a bit of a faff. Actually, the volume control may be alright. I think we ought to test it before faffing more. Just make sure that green display is clean. So I don't want to unnecessarily chase out the lubricant. So we'll just try that, because I did spray that in. There are some rivet holes on the on and off switch, whereas there weren't which went through. There weren't any that went through on the RF gain. Let's see whether we've fixed that. Next thing, my mic's coming loose. We'll just need to plug it all back in again. Power, speaker, and test gear. Yes, that does need doing. They're alright. We're still plugged into the other test set. How daft is... No, we're not. That's better. It's actually, the control's actually broken, I think. Yeah, these knobs have been painted. Can you see that? When I press on it, it makes contact. These knobs have been painted, and in putting them back on, it's managed to break the control. Yeah, that's what the issue is, not the service-all. Right, well, we'll see if we've got one on a scrap chassis. Okay, so I've recovered one from our scrap, not a lot left on this one, that Banatone 5-star that I even lent to Radio Cruncher once. So that's 100k, and this is 100k. That's the Squelch one on that radio. So we'll get that unsoldered and refitted. Okay, that's the front back on, and we've now got RF gain working smoothly. Right, we'll get the knobs back on. The thing to do here is to hold the back of the set as you put them on. So hopefully, so we want these all in the off position, the lowest position. Okay, where's the fourth one gone? You couldn't make it up, could you? RF gain. Well, I'll start putting the lids on, and let's hope that the internal speaker is working, because there's another thing you can't get, these 3.5-inch ones. Nope. Spin it round. Let's just switch it back on. Plug the mic back in. Yep. Switch it back off. Put the screws in, and I'll come back to you when I've got it on the aerial. Right, the final thing I want to do with this is we'll switch it to public address with the customer's mic in it. Testing 1 2, testing 1 2, testing 1 2. With the volume at that level, and that works fine. The volume at that level, we'll put our mic in, we'll be running with our on the air test using our standard replacement mic, and then we'll just run to that new one at the end. Sorry, that old one, original, at the end. Testing 1 2, testing. Seems a little bit louder, different inserts, all that. Let's have a flick through. PA there. Oh, it's talking, that makes a change. 19 to Roger. Well, we can actually find a channel. Good.
Talking of links, have you put that DPF cleaner in the car yet? You know what?
Right, well there you have it. Quite a lot to do to that. Harvard 420M, favourite set of all time. 7 at 134 upper tier chassis. Thanks for watching.